Hi, good morning everybody, and once again welcome to Pankaj's Echelon Tutorials. And today we are going to continue with our IGCSE chemistry session, and this is the third part of that chapter that we are already into it. And the name of the chapter, as you know, it is electrochemistry. Okay, so this is chapter number 5. The name of the chapter is electrochemistry. Okay. uh, this is for IGCSE curriculum. Okay, and already in the previous two videos, I have introduced you to the concept of electrochemistry, electrolysis, and we in the last video, I suppose, we even saw one example of electrolysis, and that was of lead bromide, okay, in the molten state. So in continuation to all that, I'm going to start this today's video, and today's video is going to be lesson number 3, lecture number 3. Okay, I'm not mistaken, it is lecture number 3. Okay, so let us get started with today's session. So in this particular chapter, electrochemistry, okay, now we have reached a point where we are going to start doing more and more examples on electrolysis. So in the process, the next example for electrolysis that comes to my mind is that of now there's a one worked example also given in your book. Okay, and you must be knowing I'm referring to the book, the course book, orders course book. Okay, orders course book, the fourth edition, right? I'm referring to the fourth edition. So in this is the latest book. Okay, and on page number 71, there's one worked example given, and let me read out the worked example for you, and let us try to understand that. Okay, so the example says that predict the product of the electrolysis of molten magnesium fluoride. Okay, so this is regarding electrolysis of molten magnesium fluoride. So magnesium fluoride will be MgF. Am I right? MgF. F2. If I'm not mistaken, it is F2. Okay, MgF2. Right. So if you want to understand this electrolysis of magnesium fluoride, that is MgF2, okay, in the molten state, okay, so there's no water involved in this, so there will be only two types of ions. So let us first write down that MgF2 will be decomposed to Mg2 plus ions plus F 2F ions. Okay, that is fluoride ions. So you'll get magnesium ion and fluoride ions, right? And these magnesium ions, as you know, they carry positive charge, so they are known as cations, and these fluoride ions will be carrying negative charge, so they are known as anions. Okay, so this is the first step, that is the decomposition of the electrolyte into the respective cation and anion. Okay. Then what will happen is, of course, the electrodes used will be either graphite or any other inert electrode. Electrodes are two types, okay, inert and active. So we are right now talking only about inert electrode. I'll come to what are active electrodes, okay. But inert electrodes are electrodes which are not reacting with any of the substance, any of the this electrolyte, okay. So they are basically inert, okay, with respect to the electrolyte. So the electrode used here is, say, graphite, or carbon rod also can be used, okay. So both the electrodes will be graphite, suppose, and one is connected to positive terminal, which will be anode. One is connected to negative terminal, that will be cathode, right? Now, I'm not going into the diagram and all that. The question here asked is, predict the products of the electrolysis of the molten magnesium fluoride. So this is your magnesium fluoride in the molten state. It will be forming these two ions, and what will happen at the cathode? Okay, at the cathode, what will happen? Now cathode is something which is connected to the negative terminal. So this negative terminal will always attract the positive ion, that is the magnesium ion. Magnesium ion 2 plus, magnesium 2 plus, okay, will be attracted, it will be pulled towards the cathode. And at cathode what happens, cathode always gives electrons, so it will give electron. In fact, it will give two electrons to this magnesium ion, and this magnesium ion will be converted into solid magnesium, metal magnesium. Okay, so this is the reaction which is taking place at cathode. Okay, so the magnesium ka ion, will take two electrons from the cathode, and it will get converted into magnesium in the solid form. Now this magnesium in the solid form will slowly steadily get accumulated on the cathode. Okay, so the product at the anode, product at the cathode, he has asked you what is the product. Okay, the product at the cathode will be magnesium metal, okay, in the solid state, right? Slowly it will get accumulated on the cathode. So magnesium metal you will be getting as a product at the cathode. Now what happens at the anode? Let us check that. At the anode, what will happen? The anode is connected to the positive terminal of the battery, okay, DC source. So being connected to positive terminal, it is going to attract the negative ion, and negative ion is nothing but this fluoride ion. So two fluoride ions, they will be attracted towards the anode, they will move towards the anode. Okay, and at the anode what will happen? This fluoride ions, now anode, it is not giving electron because it is deficient of electron, it doesn't have electron. Its job is to take electrons. Okay, so anode will accept electron from this fluoride ion. So this fluoride ion will give electrons. So I will write on the right hand side 2 electrons. Because it is given, so I am taking on the right hand side. So 2 electrons are given by the fluoride ion to the anode, and this fluoride ion is getting converted into fluorine gas. Okay, F2. Is that clear? F2 is fluorine gas. So this is the reaction that takes place as at the this thing anode. Okay, now let me write here, this is in molten state. Okay, so I'm not writing aqueous and all that. Okay, it is in molten state, so you don't have to write aqueous or anything else. Okay, so these are in molten state, so this fluoride ion will be getting converted into fluorine gas. So the product at the anode will be fluorine gas. So you'll be able to see certain bubbles, at the anode, and these bubbles will be of fluorine gas. And because fluorine is colorless, I suppose, so you'll see colorless fluorine gas ka bubbles. Okay, so these are the two observation that you will be able to see as a product. Okay, so these are the two products rather of this particular electrolysis. That's the question number 1 ka A part. Now B, he is saying write the ionic half equation for the substances produced at the different electrodes of your answer in 1A and are present in 1A. Okay, so that I have already mentioned the two half equations. Okay, so this is the half cell equation of cathode, and this is the half cell equation of the anode. Okay, so both the equations I have already mentioned over here. Okay, now next question he has asked is state whether the process are oxidation or reduction. Okay, the cathode reaction. So okay, so the question now can be asked is what is happening where there is oxidation taking place, where there is reduction taking place. Okay, so if you see this particular reaction at the cathode, this magnesium ion, they are taking in oxygen, so they are accepting sorry, not oxygen, electron. Okay, so you must have heard about this. Oxidation is OIL. Okay, oxidation is loss of electron, and reduction is gain of electron. So OIL stands for oxidation is loss, reduction is gain. Okay, RIG stands for reduction is gain. Now you have to make use of this thing. Okay, Now here what is happening at the cathode, this magnesium ion, okay, Mg2 plus, is taking two electrons. It is accepting two electrons to get converted to magnesium solid, magnesium metal. So here gain of electron is taking place. So whenever there's gain of electron, it is known as reduction. So here at cathode, reduction is taking. So can I write at cathode, reduction is taking place. It's always like that, okay? Always at the cathode there will be reduction, okay? So at the cathode, reduction is taking place because the reason also you have to write, because the magnesium ion is uh, accepting electrons, okay? You can say gain of electrons, okay? And at the anode, what is happening? At the anode you can see this fluoride ion is giving away its electron, okay? It is giving away its electrons to the anode, and in the process it is getting converted into fluorine gas, okay? So at the anode, oxidation is taking place because loss of electron is nothing but oxidation. Can you see here? OIL, oxidation is loss of electron. So at the anode, oxidation is taking place, and the reason again is because this fluoride ion is uh, you can say losing electrons. So that was one more example of electrolysis. And next is something called sort of test yourself type of question is given. So you have to fill in the blank, and answer you have to give from the selected words that are given. Okay, so let me write that also for you. This is test yourself. This is all from the textbook, okay, your course book, okay. Now he is telling you, in test yourself, copy and complete the following sentences about electrolysis using the words from the list, and the words that you have to use are compound, then you have electricity, and then you have inert. Now these are the words you have to use, okay. Then you have chemical, uh, inert chemical, then you have platinum, okay. You have molten, and you have breakdown. These are the words that you have to use to complete the paragraph with fill in the blanks, okay. So let us start answering that. So the paragraph reads that, I will read also and write also for you. So it is written that electrolysis is the dash of an ionic uh, dash when dash on dash when dash or in aqueous solution by the passage of dash, okay. Then there's a full stop, and then again electrodes, okay, are often made of graphite or dash, and are generally used in electrolysis, okay, because they are dash. Okay. So all this fill in the blanks you have to fill up from this words that is given here. Okay. So let us start. Electrolysis is the dash of an ionic compound. So from here the word will be breakdown. Okay. So it is the breakdown of an ionic. Now ionic, then compound word will be coming. Ionic compound. Okay. Electrolysis is the not only breakdown, you can use this chemical breakdown. Okay, along with the breakdown you can use this word chemical also. It's a chemical breakdown, okay, of an ionic compound when dash or in aqueous solution. So here you will write a molten. Okay, so this ionic compound should be in the molten, 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 or in aqueous solution by the passage of dash. So dash means electricity. You have to pass electricity. Okay, full stop. Then electrodes are often made of graphite or dash. Now graphite or what should come? Platinum. Okay, should be either graphite or platinum. Okay, and are generally used in electrolysis because they are dash. So these electrodes which are made up of either graphite or platinum are generally used in electrolysis because they are inert. Inert means they are not reacting with the electrolyte. So this is that test yourself ka question number 1. Now there's one more question, question number 2. In that sub question A is asking you to predict the products of the electrolysis of molten potassium chloride and lead oxide. Okay, so in A, second A, he's asking you to predict the products, okay, of number 1 electrolysis of molten KCl, potassium chloride, and second is molten it's lead oxide, PbO. Okay, so that's the A part of the question. So first let us get the answer for this. So this is molten state में KCl. So electrolysis, first let us write the decomposition reaction. So KCl will be decomposed to K plus plus Cl minus. Because it is in the molten state, water is not involved, so you won't get H plus and OH minus ion. Okay, so this is that reaction. Now at the anode and at the cathode, what will happen? Okay, so at the anode what will happen, this anode being connected to the positive terminal, this chloride ion will go to the anode and it will give away its electrons. I am writing it will give away one electron, okay, and get converted into Cl. But then Cl alone cannot exist, you should have Cl2. So you will have to get two chloride ions coming to the anode, and instead of one electron will be this chloride will be giving two electrons. Okay, so I'm writing here plus two electrons. Okay, so two chloride ions will lose two electrons to the anode, and chlorine gas will be formed at the anode. So the product at the anode is chlorine gas. Okay, same way at the cathode what will happen, cathode being connected to the negative terminal, this positive ion, potassium ion, will come to the cathode, and from the cathode it will accept one electron and get converted into the potassium solid metal. Okay, so potassium ion, okay, will be coming to the cathode and accepting one electron from the cathode and get converted to potassium metal, which will be in the solid state. So slowly, steadily, this potassium metal will get accumulated on the cathode. So the product at the cathode is potassium metal. Okay, that was the answer for this KCl. Now let us try to answer this second question, that is for PbO. So again for PbO, that is lead oxide, since it is in the molten state, first let us write the decomposition reaction. So PbO will be giving you Pb 2 plus O 2 minus. Okay, because O has 2 minus charge and lead has 2 plus charge. So this is the decomposition reaction. Now what will happen at the cathode? What will happen? Let us see. So cathode being negatively charged, okay, it is connected to the negative terminal. The positive ion, that is lead ion, will be coming to this cathode, and from the cathode it will take 2 electrons, and this lead ion will convert itself into lead metal, that is solid. Okay, so the product at the cathode, the product formed at the cathode will be lead metal. Okay, so slowly, steadily, you will see that lead is getting accumulated at the cathode. Okay, and at the anode, what will happen? Let us see. Anode being connected to the positive terminal of the DC source. Okay, it will be having positive charges on it. Okay, so this positive charges is going to attract this negative ion, that is O2. So oxygen, okay, will be, or rather oxide ion will be coming to the anode, and anode doesn't give electron because it doesn't have electron. It has a very shortage of electron. It has only positive charge on it. Okay, so this oxide ions, they will travel to anode because they will be attracted by the anode, and at the anode they will, what they will do is they will give away the electrons. Okay, so one oxide ion will give 2 electrons, okay, to the anode, and in the process it will get converted into O. That clear? But oxygen is a diatomic molecule, so you will not get only one O, you should get O2. So to get O2, you should have these 2 oxide ions. The 2 oxide ions with 2 negative charge each on one oxide will make 4 electron. Okay, so the electrons, number of electrons will not be 2, it will be 4. Okay, so 4 electrons will be lost by this oxide ion, and after losing those 4 electrons, oxygen molecule will be formed. So this is happening at the anode. So the product at the anode will be what? Oxygen gas. So you'll be able to see colorless gas in the form of bubbles, getting coming at the anode. Okay, so you'll be able to observe that. Okay, so that was question number second, ka A part. Now let us do B part. In the B part, what he's asking you is write the ionic half equation for the substances produced at the different electrodes for A1 and A2. And this reaction, half cell reaction, okay, I've already mentioned over here. So this is the half cell reaction for cathode. I'm sorry, this one. This is the half cell reaction for cathode, and this is the half cell reaction for anode. So both the reactions also I have given you. So B ka answer will be lead 2 plus will accept 2 electrons to give you lead, the solid form, and 2 oxide ions will lose 4 electrons to convert this oxide ion to oxygen. So these are the two what you can say as half cell reactions. Okay, and C part of the question is, using the answers in 2b, decide which process are oxidation and which is reduction. Okay, so this is happening at the cathode and this is happening at the anode, isn't it? So at the cathode, what is happening? This lead ion is taking 2 electrons. So taking means it is accepting 2 electrons. So it is uh, what you can say, oil is oxidation is loss. So here there is no loss of electron, here it is gain of electron. So reduction is gain of electron, rig. So for this cathode, at cathode what is happening is there is rig that is taking place. Rig means reduction is gain. Here this lead का जो ion है, it is accepting electrons at the cathode. So at the cathode we see reduction. Okay, at the cathode we see reduction. Now what will happen at the anode? Okay, so at the anode, what will happen? This two oxide uh, ions, okay, will give away 1 electron. Okay, or rather they will give away 4 electron. One oxygen atom will be having 2 electrons, two oxygen atom will be having 4, so it will be giving away 4 electrons to get converted to O2. Okay, so uh, the answer for this C part of the question is, at the cathode reduction is taking place, and at the anode, because this oxide ion is, you know, losing electron. Okay, so loss of electron is nothing but oxidation. So at anode oxidation is seen. Understood? So that was about some few more uh, examples of what you can say electrolysis, and still we are sticking to only the molten state of electrolysis. Now in the next session, because time doesn't permit me, so in the next session perhaps I'll be going with the aqueous solution may electrolysis. So how electrolysis takes place when the electrolyte is in the form of a solution. Okay, so that will be covering in the next video, and still we have many more things to cover in this particular chapter, particularly how to obtain aluminium, pure aluminium. Okay, then electrolysis of aluminum oxide. So there are a lot many things to be covered, so that we'll be doing in the subsequent lectures to come. Okay, so that's all for today, and if you happen to like my today's video, please subscribe my channel and press the bell button so that I'll be motivated to make more and more such videos. Okay, that's all for today. See you. Take care, all of you.